Hello, welcome again to another Actuarial Math with Mafeng. And in this video, I'm going to be talking about the fractional age assumption. Now, I would like to refresh our memory on one of the key notations that we have in actuarial science, that is talking about the probability of a life age X not surviving beyond age T. Now, when we look at this, X usually can be an integer, or it can be in fractions. So here we are going to be looking at the cases whereby we have these to be fractions, and what are we expected to do? Now, when you look at the life tables, you are going to see that the life tables does not make provision for fractions. Rather, we are going to have integers. So here, we are going to make use of some assumptions that have been stated, some assumptions to be able to convert this to integers and then be able to apply our life table. So as I said, this is the probability of a life age X not surviving beyond age T. So now there are two basic assumptions according to Dixon et al. That is talking about actuarial mathematics for life contingent risk. Now, they actually stated that in the book, we have what we call the uniform distribution of death, uniform distribution of death, which I'm going to call this UDD. Now, there are two basic assumptions that enable us to convert the ideas that we have here into integers. That is, say, when it is stated in fractions, to be able to convert that to integers, and then we are going to make use of the life table. So to kickstart that, the first assumption I would like us to bear in mind. Now, let's not forget, let's say Q, that's the probability of a life age X not surviving beyond T. So we are going to say that let T be between 0 till less than 1. So you can see that numbers that are found between 0 and 1 are usually fractions. So one of the assumptions that have been made in that book that I just talked about. And now it says that this particular notation, that's probability of a life age X not surviving beyond T, is assumed to be T dot QX. Now, what does that simply mean? It means that we are going to take T to multiply the probability of a life age X not surviving beyond 1 year. But of course, that is exactly what it means, because we are taking T to be between 0 and 1. And then, so what does this simply mean? It means that a life age X, the probability that a life age X will not survive beyond 1. Now, we don't usually put the 1 here. So anytime we have it this way, it is assumed to be 1. So in that assumption, it is saying that what we are having here, it's equal to this that we have. So that is the first assumption. Now, looking at the second assumption, that is the uniform distribution of death. We are going to derive, we are going to start from here and be able to get some other formulas that we are going to use in the conversion. Now, I'm going to take it directly from here. That's this first assumption, which says that the probability of a life age X not surviving beyond T, same thing as T dot QX, just as it is stated earlier on. But then we have to know that this, according to actuarial, so I'm going to say, but this we have here, that's QX is same as saying dx over, we have LX here. Now, this is not a new formula or something as well. It has been there. So since I'm talking about the fractional age, so this has been proven before, that we have, this is the probability of a life age X not surviving beyond 1 is equal to dx. Dx means the number of deaths that are age X, and then over LX. Now, LX is the number of lives that are age X. Now, number of lives, those that are alive and are age X in this particular cohort. So we can say QX is equal to DX. Now, this is not differentiation. So that's why I'm putting that below here, just a subscript here. So we're going to say DX is equal to LX that we have. So when I plug it in here into this formula, I'm going to have T dot, and that will be dx over LX. I guess that's actually clear for us to understand. Now, looking at this also, it will also be important for us to note that this particular, we have this qxt is same as 1 minus pxt. What does that simply mean? That's the probability of a life hx not surviving beyond t is equal to 1 minus the probability of a life hx surviving beyond t. Now, having this in mind, we are going to, having this in mind, I'm going to also split this by saying qx with t is equal to 1 minus lx plus t over lx. Also, we need to know that this is actually equal to this. So I'm going to say, but I have px with the t is equal to lx plus t over lx. Now remember, L means the number of lives. So that's number of lives in the particular cohort, hx plus t, divided by the number of lives in this particular cohort, hx. So this is what we call px t now that we actually have in here. So now when I plug it into this particular equation, now I'm going to see that this is qx with the t is same as saying, I'm finding the lx here. I'm going to say this is lx minus lx plus t. That's taking lx as the LCM there that we have. So we can see that here brings us down to this particular point that we have here. Now, but don't forget that we have said qxt is actually equal to what I'm having here. So I'm going to say this is t dot dx over lx, which is equal to lx minus lx plus t all over lx. So I can see that this goes with this, and then I'm going to have t dot dx equal to lx minus lx plus t. Now we need to know that this is quite fundamental. I could just make it look finer by bringing this to this other side, and then here to say lx plus t is equal to lx minus t dot dx. So now this is exactly where I want us to find us. So the first assumption here, we're able to have that qxt is equal to t dot qx. That's talking about t times the probability of a life hx not surviving beyond 1 year. But don't forget that is with the condition that t runs from 0 to 1. And of course, as I said, numbers that are between 0 to 1 are actually fractions. So now this and this are very important. So I'm going to put that somewhere by the side here. So I'm going to say the first, that's qx with the t here is equal to t dot qx. And that's the first thing that we need to know. Secondly, I was able to have this. T is equal to lx minus t dot dx. So I'm having this by the side. So I'm going to erase this. All right. Now, having this again, another assumption, even though I'm going to generate other stuff from this particular assumption here that we have, and then I'm going to write down the question and then say how we are going to solve it. So let me start with this now and say d over dt of lx plus t. Now, there's something I want to get, which it has to do with the force of mortality. What are we going to have whenever we're dealing with the force of, I want to generate actually the force of mortality. Now, looking at this now, when we differentiate lx plus t, I can still say it is equal to what I have here, lx plus t minus lx. Now, that is exactly what I have now, because, you know, this is a decreasing function. So it means that lx, when I differentiate lx plus t, it is going to be lx plus t minus lx. Now, of course, this is going to be negative because lx is greater than this. So we're expecting that as the age increases, probably let's say the starting point is actually lx, and then as the age increases, that's talking about x plus t in few months time. Yes, since t is between 0 and 1, we're expecting that probably some people would have died. So now this is actually equal to minus dx. Now that's because we have to know that dx, which is the number of deaths that we have, is lx minus lx plus t. Now what does this simply mean? It's saying that how many deaths do we have? So we look at the number of lives that we have at the beginning. So in this case, the beginning is X, and then we now look at the number of lives alive in this same cohort, maybe X plus T. That is to say, it could be in some months' time or probably in some years' time. So when I convert this, you could see that I'm introducing the minus here because this can actually, if I'm to introduce the minus here, this become minus dx, and this will give me minus lx, and this will give me plus lx plus t, which when I rearrange that, I should have this to be lx plus t minus lx, which is exactly what I have in here now. So looking at this, I'm going to say d over the t is lx plus t, which is equal to minus dx that I have in here. Now, I'm also going to just playing around this a little. So I'm going to say 1 over lx. That is to say, I'm multiplying both sides with 1 over lx. Dot, I have t d over the t, sorry, the t this way. And then lx plus t, this will be equal to, what I'm going to have here is going to be minus 1 over lx plus t, and then I have dx. Now, I would like you to know that this and this are actually different. This actually denotes the derivative of what we have here, lx plus t. Now, when I also multiply both sides with minus, that's say minus 1 over lx plus t, thus d over the t, lx plus t. When I multiply this with minus, it becomes dx over lx plus t. So the minus actually disappears. So when we look at this, this is perfectly the definition of mu, that's the force of mortality of x plus t, is actually equal to the whole of this that we have. Now I could put this by the side by saying the force of mortality here is minus 1 over lx dot d over dx. This is the x as a derivative of lx. So this is actually the definition for the force of mortality at age x. So when I look at this, you can see that it looks just like that, but then here we are having x plus t in here. So that simply means that I can say mu x plus t is going to be equal to d subscript x over l subscript s plus t. Now, this is very fundamental now. So now we can see that from just this assumption, I've been able to generate this and then also be able to show that the force of mortality x plus t is equal to what I have is, again, with the condition that t ranges from 0 to further. So we're able to show that mu x plus t is equal to d subscript x over lx plus t. Now, I can introduce something here by saying d subscript s over lx dot lx over lx plus t. Yes. Now, that's to say I'm getting this. This was gotten from here. All I just did was just to introduce lx and then lx here, which, of course, if it cancels out, it still brings me back here that I have. Now, don't forget, earlier on, I said qx is same as d subscript x over lx. So that handles this. So I can say this is qx, right? And then here also, you need to know that px with the t here is same as saying lx plus t over lx that I have here. So now how can I make it look this way? If I take the reciprocal of both sides, that gives me 1 over px with the t, and then this becomes lx over lx plus t. That's when I take the reciprocal of this and this. So when I take the reciprocal of this, it swaps, and then we have here. So looking at this here, I can say this is dot 1 over px with a t here, which, of course, I'm saying mu x plus t is equal to qx over px with the t. So you can see that this is very important. You know, it can also be splitted into something like this, qx over 1 minus, yes, of course, this is 1 minus qx with the t here. And we know that since we are dealing with uniform distribution of age, and we have already said earlier on that this is same as saying, with the x here, 1 minus t dot qx. So now I've been able to show that mu x plus t it's actually equal to this. Again, as I say again, these ideas are actually gotten strictly in these ideas actually gotten from actuarial mathematics for life contingencies. That's talking about Dixon et al. No, so now this is a very important formula that we have. So I'm going to put it here by the side by saying mu x plus t is equal to q subscript s 1 minus t dot q with the x in here. Now, don't forget for all of this, it means t ranges from 0 to 1, and that's for the fractional age assumption. So now, having this, I'm going to solve a question. So I'm going to write a question here on the board and then be able to make use of all these ideas to be able to solve the question. So let's say given that we have Q36 to be 0.00075, and that is to say the probability that a life age 36 will not live beyond, will not survive beyond 1 year. And we also have Q70 to be 0.03950. And that's what we have. Now, this is actually derived from life tables, I think the English tables. So we are going to find, we're told to find, and the first year we have Q36, 1 over 2, 1 over 4. And then secondly, we have, that's mu 70, 1 over 2. So you can see that the ages that we have here are in fraction, as well as the t that we have here is also in fraction. So how am I going to go about this? This is quite simple. So I have the solution here. Now take a look at this. I'll prefer, this is 36, 1 over 2, 1 over 4. I'm going to change this to decimal. I think it's more flexible for me to work with it that way. So I'm going to say this is 36.5, and then this will be 0.25, I guess. Yes. And that will be 0.25 exactly. So now this that I'm actually having here, I would like to make use of some of these ideas, but then you will notice that x is an integer. X have to be an integer for this to work out. And then you see here what we are having here is not an integer. So we have to think on how to be able to resolve this to have probably x to be an integer. So I'm going to say here is 36.5, and then this is 0.25. This is same as saying 1 minus p 36.5 and 0.25 that I have here. That's the probability that the life age 36.5 will not survive beyond 0.25. Now, this is same as saying 1 minus, I'm going to have L, that is, remember, with this, same as Lx plus T over Lx. So that's what I'm going to have here to say this will be 36.5 plus 0.25. Remember, all these are subscript. And then we have L 36.5 that we have in here. Now, I'm going to add this up together to say this is 1 minus what I'm going to have here will be L, and that will be 36.75 over L 36.5. And since I have this again, I will say this is 1 minus, here I'm going to introduce something, just some very little, and say this is 36.5 divided by, sorry, that's 75 divided by 36 dot L 36 over L 36.5. I guess that's not confusing, because if I to cancel this out, I'm still going to have this back in here. So I'm going to erase this way, and I'm going to leave these values because I'm going to be making use of them. So now here we will see that what does this simply mean? It means 1 minus, when we have this, I can say this is same as saying the probability that a life age 36 will not survive, will survive beyond age 75. That's 0.75. This is exactly what I have. And then dot, this will be 1 over, because when you see this, you can see this is more than this. Usually, formula says this is greater than this, as in we have Lx plus T, and then over Lx. So you can see here we have 36.5. So I'm going to say that is 1 over probability that live age 36 survive beyond 0.5. Now, when I bring this together, that simply means that what I have here, let me put this way. So Q 36.5 and 0.25 will be 1 minus P 36 and then 0.75 over P 36 and then 0.5 that I have here. Okay, and since we're given this to make use of, and they didn't give us something like this, so, and I know, of course, I can be able to get this directly from that because we know that Qx with the T is same as 1 minus Px with the T, right? So, or better still, I could say that Px, T here is same as 1 minus Qx with the T here. So that's what I'm going to use to say 1 minus, here will be 1 minus what I'm going to have here, Q36 and 0.75. Just writing it a little bit smaller. 1 minus, then this will be Q36, 0.5. Okay. Now, but based on the assumption, we know that here, so I'm going to say this is 1 minus, I'm going to have 1 minus, and then here will be 0.75 and Q36 over, now you can see this, that 0.75 is not a subscript. So this is 1 minus 0.5, then Q36. So this transformation enables us to make use of what we are actually given. So what I'm going to do is to plug these values in here. When I plug these values in here and then using my calculator to solve, and then I'm going to have the probability for that question. So this becomes, I'm having 1 minus, and then I have 1 minus 0.75 into, I have the 0.00, yeah, that's 3075 over, not with this, this is equal to, so don't forget that this is minus and 1. So, all right, so we see that here is 0.75, yeah, 0.75, and then Q36, which I'm having this here. Then here will be 1 minus 0.5 into 0.00075. So having that value in there, let me just do that quickly. 1 minus, we have 0.75 times 0.00075. And then that will be divided by bracket 1 minus 0.5 into 0.00075, close the bracket, and then I have 1 minus answer. And of course, the whole of this gives me 0.0001875. And okay, I have this there. So now this is that's for the first one that we have. That's this Q36.5, 0.25. This gives us 0.0001875. That's exactly what I have. So you could see that I have to use the ideas, some little transformation to be able to arrive at whereby I could be able to make use of what I have been given. Okay. All right, that's it. So we take a look at the second one, that is to say the force of mortality of this. This is quite easier because we could be able to use that in here. So now I can say that, of course, here I'm dealing with 71 over 2. Now this can still be 70.5. And of course, I can make it as this is 70 plus 0.5. And you can see that T is actually between this. So you can see 0.5. You can find 0.5 in here. So I'm going to make use of this to say This is 70, 1 over 2, which I'm taking my t to be 0.5. So I'm going to plug it in there to say this will be 70 and over, that will be 1 minus my t, which is 0.5, and then 70. So that's exactly what it is. So this is quite faster. So I'm going to have this value 0.03930 over 1 minus 0.5 into 0.03930. Yeah, there. So computing this is 1 minus 0.5 into 0.0393 0, I guess. Yes. And I have 0.0393 divided by that, and this gives me 0.040088 probably. So now that's it. So that actually ends it. So I believe that this is quite clear. So please, you can subscribe to my YouTube channel, because I'm going to be dropping more videos for other actuarial maths as well as other maths too. And I hope you understand what I'm doing. Thank you.